Hello and welcome back. Let us try to understand another metric to measure the regression model's performance. The R-square score, which is one of the important metrics for regression problems accuracy to measure the regression problem's accuracy. So R-square score generally tries to look at the distance between total sum of squares and residual sum of squares. So let us try to look at how much R-square score we got on the simple linear regression first, and come back and try to understand this total sum of squares and residual sum of squares. So here on this model, we have got 0.908, that means 90.8% accuracy on this model. The R-square score is 90.8%. So R-square score generally looks at the distance between total sum of squares and residual sum of squares. Let us look at the formulas of total sum of squares and residual sum of squares. Total sum of squares is the distance between, squared distance between the actual value and the predicted value. And total sum of squares is the squared distance, sum of squared distance between the actual value and the mean of the actual value. So here the R-square score is trying to look at the distance between these two, right? The RSS and TSS. When you look at the formula, RSS is trying to measure the distance between actual value and the predicted value, the intelligently predicted value. When you predicted y cap, you have used a linear regression algorithm or some other algorithm and tried to understand the pattern inside the train set and try to make prediction. Right? That's an intelligent way. And trying to look at the square distance, right? Square distance, sum of all the square distances. That's the residual sum of squares. But when you look at total sum of squares, it is just taking the mean of all the y values or the actual values and trying to take the distances between actual value and its mean and trying to sum, square the values and sum it. That's called as total sum of squares. So I can say that the total sum of squares is trying to measure the accuracy of a dumb model which is predicting the mean as the prediction. For every row, the same prediction. The mean of the actual value is the prediction, right? So that's the dumb model. And RSS is the root mean, the residual sum of squares is the intelligent model's predictions distance between the actual value and the predicted value, or the error when you predicted using the intelligent model, right? So this intelligent model's prediction should be far from the dumb model's prediction, right? So that's what the R-square score is trying to measure. If you look at R-square score's formula, it is trying to look at the distance between TSS and RSS. Dumb model's accuracy minus intelligent model's accuracy. Intelligent model's accuracy should be very less and dumb model's accuracy should be more, because if you try to predict mean as prediction for all the rows, for every row you will get some difference, and when you square it and sum it, it's going to be a big number. And RSS, we are saying it's an intelligent model's prediction, right? When you look at the formula, intelligent model's prediction, the y cap should always be close to y. If it is if the y cap is always almost close to y, it's going to be almost zero, right? Almost zero for every row. If the model is working too good, almost zero for every row, and then you sum all zeros, it's going to be zero. If you subtract 0 from TSS, the numerator is going to be TSS. TSS divided by TSS is going to be 1. That means if the model is working too good, RSS value is going to be very close to 0. Immaterial of TSS value, the R-square score is going to come close to 1. If RSS and TSS are equal, right, almost equal, what happens? On the numerator you will get 0. That means R-square score is going to become 0. But that means the model is not working good. The model is predicting as good as mean of the y value or the target value. So you no need to build a model to predict mean as the prediction, right? You can just take y values and take mean and say that is prediction. So if it is equally working as TSS, so when you get R-square score 0, that means it is equally working as TSS or predicting mean. It is equal to the model is predicting mean, right? Mean as the prediction for every row. That is the R square score. R square score can be negative. Generally, it is not. R square score can be negative. When it will go negative? When TSS is less than RSS, it goes to negative. When TSS, the RSS is too big than TSS, that means model is not at all working good, right? So that is R square score. The R square score has got one disadvantage. When you add more features, more input features to the data set and try to build a model, the R square score increases irrespective of whether the newly added feature is adding predictive power to the model or not. When you add 10 more features, the R square score jumps from 0.9 to maybe 0.91 or 92. So that's the disadvantage. To avoid or solve this disadvantage, we will use adjusted R square. Adjusted R square is a mathematical manipulation of R square, which actually tries to nullify the effect of newly added feature when it is not useful. Right? When the newly added feature, maybe 1 or 2 or 10, are not adding any predictive power to the model, the adjusted R square score will try to reduce or try to keep the R square score as it is. Here in this formula, we are using 1 minus R square score into m minus 1 by m minus n minus 1. Here, m is the number of rows, n is the number of columns or number of features. So that is about the R square score and the adjusted R square score, the metrics for regression models accuracy calculation. Thank you.